Alright, you're welcome back to Integrated This is Mathematics as usual. We're going to start it by previous session. So in our last session we were talking about what about the homogeneous function. So now hope you have proper knowledge about homogeneous function, right? So at that moment, we were able to just represent this homogeneous function as x to the power n times half of x upon y, right? So with our previous knowledge, we'll be able to understand what about this one, right? Okay. And now I'm going to discuss how few errors identities, and I'm going to derive them also, how it comes, and we may be able to work with these errors identities when we are dealing with this type of homogeneous function, right? So let me explain you the first one. Right, we're going to talk about them very briefly. So this is the first one. This would be our first one. As usual, this is our z. Phi of x comma y will be denoted with this z, right? Sorry, then z is a homogeneous function of x and y, right? Okay. And then x times partial z with respect to partial x plus y times partial y, z with respect to y is going to be equal to n times z, right? So if you could derive it, this can be used, this can be applied related to this type of homogeneous function directly, right? So let me show you how to derive it. This is pretty much easy to do, right? So this will be function z, right? So I'm going to derive both sides by partially differentiate with respect to x. So there is a multiplication x to the power n times half f prime of x upon y times 1 upon y, right? Because this is just a constant with respect to x plus half of x upon y times n times x to the power n minus 1, right? Okay, within basic knowledge you may be able to understand it. So on purpose of creating my left hand side, I'm gonna multiply both sides by x, right? So hope you could understand it. Okay, right? So let me put it here, right? Okay, so the next step also will be go like that. So on my economic purposes, I'm gonna edit this to avoid take much more time, right? Okay, then differentiate both sides by y with respect to differentiate both sides by y with respect to y partially, right? Okay, then this is just a constant x to the power n times f prime of x upon y, right? This also is a constant. It becomes minus 1 upon y squared, right? Okay, so that's all. So we need to multiply both sides by y, so it becomes at rest. This step comes through these two scenarios. I'm gonna add these two expressions together, right? So let me show you how it will be look like. X times partial z with respect to x plus y times partial z with respect to y. It's going to be equal to here x to the power n plus 1, right? Upon y times f prime of x upon y. So then these two expressions, these two terms will be cancelled out together because these are equal and opposite, right? Okay, then minus x to the power n plus 1 upon y times f prime of x upon y plus n times f of x upon y times here it becomes x to the power n, right? So it becomes x to the power n. So clearly we know with our previous examples what about this guy here. This is just a z, a homogeneous function. I was just select this homogeneous function, right? We could pick this homogeneous function. So yeah, it becomes n times z is going to be equal to x times partial 0 respective to x plus partial 0 respective to y times y, right? Okay, and this is our first Eurals identity. So at the next we need to prove this one. Just try to do it at home yourself, right? Then I'll be proving that also, right? Okay, then the next proving will be z should be chosen as a function of u, right? Now at this moment we could just I'm gonna take this z as a concrete function of u, right? So the variable was chosen as u, the domain is just u, right? At this moment x and y, both of them were considered together, right? So then we need to get this substitution, and you need to derive this guy, x times partial u respective to x. This it looks pretty much close to this expression, but there is something different with this one, because we may be able to use this guy directly for representing this homogeneous function as a variable, as a domain of u, right? So then y times partial u respective to y is going to be equal to here what n times f of u upon f prime of u. So you need to show this one. This would be a second identity, right? Okay, thank you. If you have any doubt, please be kind enough to put them, right? Okay.